factoring we've been doing, but also solving other types of equations today. Like I said, when I assigned this assignment to my other class that was ahead of you guys, I realized the factoring we needed to know was more like kind of robust or tougher than it had been. So that's why we took the day for factoring. So hopefully the factoring day ended up helping you guys to make today a little bit more doable. But this is going to make us recall some other types of solving we've done in previous lessons. And I might add a problem or two to the back, kind of depending on how we feel like we're going on this. So the warm-up questions, though, is trying to remind you guys we can solve these using factoring, or if they're already factored, we can use that zero product property. So I can set, since these are being multiplied together and they equal 0, I can set both of them equal to 0 to solve. Now technically you could have factored the x squared minus 9, but I think it's just as easy to solve that one by square roots. So some of these problems we're going to get lots of different answers. This one we're going to get 3 different answers. So you don't want to forget when we take the square root, we can't forget the positive and negative answer. So square root of 9 is plus or minus 3. And then I go to solve the other half of this. And so we also get a negative 3 halves. So we get 3 answers technically for this problem. Now the next one has some similarities to what we talked about yesterday, but it's not exactly like our last class. So any thoughts on what we want to do first in letter B? Anyone see it? What's that? I didn't hear you. Okay. Yeah.
Factor out the x.
Yeah, there's an x that's common among everything, so we want to pull that x out to begin with. If we do that, and so watching for like those common factors, those would be helpful as we kind of work through this, because x to the third, we really don't know how to factor something with 3 terms and an x to the third in the front. So we divide that x out, because it's divisible out of all of these. Oh, it should be a negative 24. So yesterday, I thought I had figured this out. Oh, there we go. So my algebra students figured out I can erase. I just need to use the side of my hand. I didn't know that till today, or yesterday. So negative 24. Now it makes what's inside the parentheses a lot easier to factor. This is that easy type of factoring where I know it's going to be x times x. I want to multiply to get negative 24, but add to get positive 2. So what are our factors? 6 and 4. Positive 6, negative 4 to get that positive 2, right? And then this time when I go to solve, again, I'm going to have 3 different answers. And again, that third power is kind of a little bit of a giveaway that you can have up to 3 answers for this problem. Sometimes you won't see all 3, or some of them will be like imaginary, but we won't deal with imaginary yet. So we move that 6 over, we move the 4 over, so we end up with negative 6 and also positive 4 as our n0. All right, the first set of problems we're going to do, we're not actually going to be using what we call chunking quite yet, but I'm going to kind of just say that our section is, bless you, is you're going to kind of watch out for problems that look like problems we're familiar with, but aren't exactly the same, but we can kind of use what we know. So if you look at example 1 there, hopefully you notice that that problem, like, obviously it looks more complicated than the ones we just did, but there are some similarities there. And I'm hoping you see that. in my opinion, and hopefully, I mean, obviously, I wrote the problem, so I know what I wanted it to look like, is, to me, this problem, oh, I didn't have the chunking up there. Let me put that back. Oh, and yeah, so we'll do chunking here for this. Now what I mean by that is basically we're going to use factoring. So I should say using factoring or substitution, and maybe kind of and or, to help us solve more complicated problems. Today is we're trying to kind of like make a really tough problem look easier in our opinion. So it's kind of like we're going to rewrite the problem or like kind of picture it a different way. It's the fastest junior meeting ever. So looking at example 1, again we have not, I mean maybe you guys did this a little bit in Algebra 2, I don't know, but we've really not very often factored something with an x to the 4th. But I'm going to kind of just like a quick little tip here. This really looks a lot like so in my opinion, this problem looks a lot like x squared minus 7x plus 12, which is something that if I gave you that at this point, I hope you'd be like, oh yeah, I know how to factor that. So kind of using the fact that we know how to factor something like the bottom, but it looks really similar, let's use the same strategies and see if it makes sense. So down here, I would have started this with x and x, right? So with x to the 4th, what do you think we should start with? Because x times x gives me x squared. What times what's going to give me x to the 4th? X squared. So why don't we try that? Try x squared and x squared. Because we want to get x to the 4th instead. And then does it work that we can just say multiply to get 12 but add to get negative 7? What multiplies to give me 12 but adds to give me negative 7? Negative 3 and negative 4. So, but we always do want to kind of check this. Kind of check the O and I term and make sure it works out. This ends up being a negative 4x squared. That makes sense. Negative 3x squared. That's how we get that negative 7x squared. So using what we know about factoring with simpler problems, we can then factor something that's more complicated. Now, I use that zero product property to solve these. So I'm going to set them each equal to 0. Now the solving piece is probably a little more complicated than we're used to. It's not just a really simple one-step problem. Still not too bad though. I move the 3 over, move the 4 over. I'm going to take the square root of each of these. Now square root of 4 is really nice. Just 2 and negative 2, right? And so some of our answers are going to end up kind of awful like this. Square root of 3, well, it's not really awful. It's just not like a nice number. So we're just going to say plus or minus the square root of 3. So in this case, we actually have 4 answers for this problem that works. So there's 1, 2, 3, 4, and the 4th power kind of tells us that that's the most answers we can have for that one. Okay? Our next one here that we're going to do, again, is another complicated one, maybe a little step further, so I'm actually going to give myself a little more space and move this down here a little bit. Sir, I'm like, what are you all looking at? Like, So again, try to think about, and I just gave myself some more space because I can't write that small, but so in my opinion, this problem looks a lot like 2x to the second minus 3x equals 35. So it's, oh whoops, oh no, we're okay. It looks a lot like that. So I'm going to treat it as if it is that type of problem. So what would we do first in this problem? What do these all have to look like to begin with? Yeah, move that 35 over. We want it to equal 0. Now, this is the kind that we have to think about. Actually, I feel like we almost did this exact problem. Maybe this is even one of the questions you guys might have asked. Yeah, this number 13. It actually is like the same problem as the one you guys just asked about in the homework. This is the same factoring problem. It's just now that rather than being squared, it's to the 4th power. So I know my factor is going to have to be 2x squared and then x squared. Because to multiply those together and get 2x to the 4th, we need to incorporate the higher powers there. And then 35, we said it was negative 1 and 35, negative 5 and 7, negative 7 and 5, or negative 35 and 1. And you guys probably have it right there in front of you, but I think we decided it was 2 times 5 and then 7, right? So negative 5, positive 7. Because that will multiply to give me a negative 10, but then a positive 7, which would add to give me 3x. So we're ready to set these two up. And this is a good one to talk about because this is kind of, we're going to talk about what happens in this half of the answer. So I'm going to move this 7 over. I'm going to divide it by 2. When you go to try to take the square root of negative 7 halves, what happens? What's the issue there? Square root of a negative, what happens? It should give you an error message. You can't take a square root of a negative without getting an imaginary answer. We are not going to go with imaginary right now, so we're just going to kind of throw this out as an answer for right now. Eventually we'll deal with imaginaries, but right now we're going to stick to just real number solutions, just to kind of keep this section not completely insane. So, so if you put the square root of negative 7 halves or the square root of anything negative, it's going to give you an error message in your calculator, because then we get an imaginary solution. So in this case, we only get the 2 answers. Sorry, I went through that one fast because we had done that one just like a few minutes ago. So, all right, the next 2 type of problems are reminding us on how to solve other ways, like using exponentials. So we're going to talk about that. So the next 3 and 4 here are going to you guys thinking about exponential functions and logarithmics that we had talked about previously. So hopefully you notice example 3, treating that one like any other quadratic we'd be factoring. I'm going to suggest you make it equal 0 first. So I'm going to move everything to the left side of that equation. So I'm going to move both of these over here. I'd like that first term to stay positive. I moved everything over. And this probably looks really intimidating. But again, try to think about this as if this were just like a quadratic equation. And instead of like the e's, it's x's. So it's obviously has some complication to it, but it has the three terms we're used to. So I'm going to kind of try to treat it this way and see if that'll end up making sense to us. So two things need to multiply together to get e to the fourth 4x power. How would I get e to the 4x power? Think about how we got just x to the fourth with two things multiplied. Squared, right? So now if I make that e to the 4x, it's going to be e to the 2x and e to the 2x. 2x and 2x is 4x. We just add those exponents. And if you're like, I didn't know I could do that, you actually did know you could do that because of exponent rules. Our exponent rules said we're just adding those exponents together. We haven't done many like that where they're variables as well, so that's extra complicated, but it's okay for us to, push ourselves a little bit further here. If this was a normal quadratic, I would multiply to get 36, but add to get negative 13. Multiply to get 36, but add to get negative 13. 9 and 4. Negative 9, negative 4. And at this point, you're like, well, that doesn't look much better because that looks awful to solve, but we'll talk about it. So again, this is new to you guys, so we're going to do e to the 2x minus 9 equals 0, and e to the 2x minus 4 equals 0. We'll move that 9 over. Move the 4 over, same thing. I'll do that one in a second. Now, how do we solve with e? You guys remember? We have to use ln. So we're going to switch this to ln, and I'll kind of just ignore this one for right now. Maybe I'll move this guy over. I'm just going to give myself some space here. So when I do this, it's ln of 9 is going to equal to x. I had a moment where I forgot how to switch that. So remember, ln is base e. And so we take the log of whatever the exponent equaled, and then the exponent becomes what goes over there. So kind of try to remember all our different log rules. Log base b of x equals y. This is b to the y equals x. So remember how we're switching those around. So ln of x equals y is e to the y is going to equal x. So kind of those two rules here. So when I go to do this, ln of 9 is something I have to do in my calculator, because I'm assuming most of you guys don't know what ln of 9 is off the top of your head. If you did, it'd be kind of weird. Like math, smart, weird. So we get like 2.2-ish. ln of 9, I just put that in my calculator. Now I'm just going to divide by 2. And I got like 1.1 for my x as one of my x's. And I still have to solve that other equation. I move that 4 over. So we're going to do ln of 4 equals 2x. being multiplied, so I'm going to divide. And I get like 0.7 for my other x. It's been a while, so it's okay if you forgot how to solve with e. That's why we review it and talk about it. We'll do example 4, then we'll take a little break because I know we've been doing a lot. We'll take, like, maybe we can even step outside because it's like the last nice day of the year.
Miss Augie, I don't like this unit.
What? You don't like this unit?
No.
All right. So we're going to look at example 4 here. Sorry, I just erased that. Does everyone have it? All right. Sorry, Tiffany. You just have to divide by 2, right? All right. Now this next one is just reminding you guys about our log and ln solving. So just trying to remind you guys how to solve something like this, how we get it out of the exponent. So now this one, rather than, I can't figure out what that x is because it's a power, so we switch it to log. So again, kind of using the idea I wrote over here. The log becomes the base, becomes like the base here becomes the base here. We're going to write that as 12 is going to equal the exponent. Whoops. So being able to write this back and forth, again, we did this a few chapters ago. It's been a while. So now the question is, does anyone remember how to do log base 3 of 12 in your calculator? Do you remember? What is it? Yeah, it's log of 12 over log of 3 to figure that out. And this isn't bad for us to review this now. I mean, obviously we're going to test on this at some point, or take an exam on all this log stuff as well. Like, it's been a while, it feels like. So this ends up being 2.26. So if you didn't get 2.26, double check like your parentheses and those kind of things. So you might want to close it off twice because you put the parenthesis in the front. So then divide by log of 3. Yeah. Are we getting that to work? So I subtract 1 here. And I get 1.26 equals 5x. And then I'm going to divide by 5. All right. Should we go take a little walk?
Yeah.